Good morning. Can you hear me? Thank you, Filippo.
Yeah, okay.
Thank you, Stephen. 5 people today. All right. Still a little light on the attendance, but okay. Nice to see all 5 of you. Today, for those of you watching on tape, is October 7th, 2020. And once again, we're still here in the middle of the pandemic at Boston University. And this is QM222 quantitative methods. And what we're going to do today is we're going to go to the All Sections website. So let me boot up All Sections website. The question tools. Let me share my screen so all of you can see. So here's question tools. We're going to go to the All Sections website. We're going to pick in-class problems, and we're going to do problem set number 8 together. Problem set number. So what we're going to do is we're going to open up handout 6.8 movies data subset.xls, which is located under resources. And we're going to run first the regression of lifetime gross on budget using the movie data. And hopefully all of you get the regression and write it down there. And then I'm going to send you off into breakout rooms. And the question is, can the breakout rooms come up with number 2? What are the coefficients both on the constant term and on the budget term mean? So let's work together. Let's go resources. Data sets. Handout 6.8, movies data subset. We'll open it up. And then once that opens up, I'll share the screen. Sorry it's taking so long. So we've already taken a look at this, but let's just do it again real quick. The first column, column A, is the movie name. The studio that produced it is column B. Lifetime gross is how much money this is taken in at movie theaters. Lifetime theaters are the number of movie theaters that it played in. Opening gross was the opening weekend, how much money it earned in movie and ticket sales. How many theaters it opened in, what year the movie was made, and then because there's seasonal effects, so we're going to look at seasonal effects in a couple of moments, the month and day are really important, and budget. So what we'd like to do is look at column I, budget, and see if that explains lifetime growth. So your goal is to run a regression right now, using column C and column, what was budget? Budget was column J. Column C and J, and I'll be quiet for a minute or two, and then I'll show you what I got for results. Does that make sense? Any questions?
Professor, I had a question.
Go for it.
Which column do we input as the y-axis and which is the x-axis?
So which is the y-axis? The y-axis is lifetime gross, which is column, lifetime gross is column C, and the x-axis is budget, which is column J.
Okay, thank you, Professor.
Okay, so most of the people in class have done it. So let me show you my answers. Hopefully you got the same one. And let me just say, if you have any questions about today's lecture, please stop me. Because I would say handout 8 is very much like what a midterm exam kind of question would be like. Here's a data set, run the regressions, explain the coefficients, make predictions. This is really what we're trying to train you to do in QM222. So I think this is a good sample of what you need to perform well on the midterm. Okay. So if you're having any questions, let me know. Data analysis, regression. We'll pick OK. And how do we know the X and how do we know the Y range? The Y variable is always the thing on the left-hand side of the equation. The Y variable is always the left-hand thing on the side of the equation. Let me stop sharing for 1 second and bring back up the class website. So we click in-class problems. Number 8. So what we're going to have is lifetime gross, run a regression of lifetime gross. And then on budget, budget means budget is the X, or there could be multiple X variables. So, and a couple more questions. We're going to look at not only budget, but we're also going to look at whether the movie happened during the summer. Okay, Y range, the C column. The X range is going to be the J column. Labels are in the first row. And what happens if I pick constant at 0? What that means is something very simple in this particular one. Because lifetime gross is the Y variable and budget is the X variable, if I pick constant as 0, in this case, a budget of 0, yep, they can see. A budget of 0 means lifetime gross of 0. You spend nothing on a movie, you get nothing out. Now, let me say that this does not happen. In Hollywood, there have been a number of kind of blockbusters with almost no budget. The most classic example in the last 50 years was something called the Blair Witch Project. A couple of people in their 20s from film school went out with a handy cam, a little thing, and their entire budget, I think, was less than $10,000. And the Blair Witch Project, I don't know, somebody Wikipedia took in, I don't know, 50 million or something ridiculous. All right? So most movies have budgets that are consummate, that sort of match up with lifetime gross, but every now and then, every couple of years, out comes a movie with almost no budget and ridiculously high sales. Anyone on Wikipedia the Blair Witch Project and see what their ticket sales were? Go ahead.
The box office was
248 million, okay? A bunch of people in college with a handy cam, right? Now that is pretty amazing. 248 million with basically no budget. And they were not expecting to make a $248 million movie. Thank you. So we're not going to have constant at 0. We'll pick OK. Now it has the upper and lower 95%, which we talked about last time, yes?
So the constant is checked out as 0. Is that always in regard to budget? Because in this specific situation, it's in like regard to budget, but I'm just confused how this would apply to something else. Like the constant varies from each problem, right?
So when you click that button, you say, don't put a constant in. In algebraic terms, we have this Cartesian coordinate, x and y. I don't know if that sort of makes sense in your head. And what you're saying is by putting the constant 0, you say the line always has to go through the intersection of where the x-axis meets the y-axis. If you don't click constant 0, then the line can go anywhere. It can go anywhere through the y-axis. The line can be this way, the line can be this way. But when you click constant 0, you're forcing it to go through the x-axis and the y-axis.
Yeah, so it's kind of like based on, say, you can't really like go under, let's say, like you have like a graph and like it goes like 10, 20, 30. Like the 10 is the line, which is the constant. So
Yeah.
like, if there isn't, but if you check the box, that line goes away.
It goes down to 0. So instead of starting at 10, you force it down to 0.
Okay, thank you.
So sometimes you really do want to force something down to 0. Okay? There are occasionally cases, and this is why I say only check, never check constant 0 unless you know what you're doing. You know, you say it has to be 0. When the x value is 0, the y value must be 0. All right? But unless you come up with one of those cases, and I'm sitting here thinking at the top of my head going, can I come up with any case off the top of my head where it must be 0? And I'm like, I'm drawing a blank right now. Go ahead.
Wait, so when you ran the regression, you unchecked constant 0? I thought you was.
No, never check that box.
Oh, okay.
Never check that box unless you really know what you're doing. Never check that box unless you really know what you're doing.
Professor, I have a quick question, not about the regression itself, but more about the 95% and the R squared. So we see on the intercept and the budget that both of the coefficients are like within the 95% range. So that's 2 standard deviations. So we're pretty confident about that. But then when we looked at the R squared of like, it's like 38%. I'm pretty sure, I'm not sure if, I think the like limit was like 40, like anything below 40 was not a great R squared number. So I was just wondering like, how are we so confident with the intercept and the budget, but not like the variation in the dependent variable and like the R squared is just not that great.
You should talking about R squared, and we're not doing R squared for another week and a half. All right, but R squared goes from 0 to 1. 1 means, or 100%, means it's a perfect fit. The x variables explain all the y variation. A 0 for R squared means budget explains nothing of lifetime growth. 38 means this one variable, budget, explains 38%, 38.4 for those of you who like precision, of lifetime growth. And what I'd say, Ayush, is that's pretty good for one budget, given we have all this other data. So when we do multiple regressions, we're going to have budget, we're going to have season, we're going to have who directed it, you know, all kind of information. And we'll push that R squared much closer to 1. But for the time being, just having one factor, I think is not too bad. So Ayush basically means I look at one thing, like homework, your grade on homework problem number 3. I haven't done it yet. And I say, from that, I can basically predict your final score. And you're like, whoa, that's pretty good, JC. So I think I'm predicting 1/3 of all the difference in final ticket sales, total lifetime gross, with just one variable is not too bad. I don't think budget should hang its head in shame. Does that answer your question, Ayush?
More than perfectly, thank you.
Okay. All right, real quick, we see upper and lower 95%, and then it repeats upper and lower 95%. We don't need upper and lower 95% repeated twice, so I'm just going to clean it up and delete it. Why am I picking this, and why will I do this over and over in the semester? Because you want to present your results in the most minimalist way possible. Because when the CEO is there, the CEO doesn't want 1,000 numbers up there. The CEO wants only a few. So repeating 95% upper and lower, the same numbers, doesn't add any extra information, just makes things confusing. All right. So we have some coefficients, and my coefficient was 15.5, and the budget is 1.07. And I'm going to send you off into breakout rooms for just a couple of minutes. And your job is to come up with simple explanation for both. So I could write something here, and we can write something there. Does that make sense? So on the exam, it's, can you explain these coefficients? That'll be like the question. Questions before I send you on? So I guess turn, face your neighbor or something like that, or make a guess.
I think that the objective are every $1 million, every $1 million. Well, like I try to do the time goes well, I guess at the like definition if you have well basically if you have a budget of $0, you the whole letter. Oh, no. So I was saying that like, it's like I did try to find the book. Really, plus where that that's not how it goes. So yeah, like I guess the whole thing would be like when we invest $1 million, so we had a return of $1 million plus with a zero dollars is their budget. Yeah.
All right, the breakout rooms will close in about 25 seconds. So breakout room 2, you seem to be back. It looks like Serenity, Haley, Lay, and Harvey. Maybe you can text message each other. I'm going to ask breakout room 2 to tell us what the constant means. And then breakout room 3 is Ashley, Christopher, Kate, and Harry. So I'm going to ask you to tell us what the constant, what the coefficient on budget means. All right, so we have somebody, a volunteer from breakout room 2. Tell us what the intercept tells us.
Yeah, sure. So the intercept tells us that if they were to spend like nothing on their
All right,
budget.
type slowly. Okay, not that fast a typewriter.
Oh, okay. Oh, sorry.
Then nothing
On budget,
on the budget.
then the movie will earn
Yep, we'll earn
15.5 million.
$15.5 million. Not bad. Maybe we should all go into Hollywood. What was your name?
Denise.
Denise. Maybe you and I should go and become movie producers, right? $100, you chip in $100, we'll make $15 million, we'll both be happy. I tell you what, you get 8 million, I get 7. That sounds good?
Yeah, that sounds pretty good.
Okay. All right. Breakout room 3. Do we have somebody who's going to tell us? Excellent job, by the way. Breakout room 3. Do we have somebody who's going to tell us the budget coefficient? What is that? 1.07 tell us.
So we weren't completely sure, but we talked about if you spend $1.07 million on budget, that's how much your gross will increase. Like that's the
Pretty close, pretty close. I would just flip the words around a little bit. If you spend 1 million more on the budget, then what happens to the gross? Then lifetime gross increases on average by, what's the number? Tell us that figure you just said.
1.07.
$1.07 million. Excellent. Group 3, pat yourselves on the back. So the idea is if you spend $1 million more on the budget, lifetime gross increases by an average of 1.07. Let's make it 10 million. What if we spent 10 million more on the budget? How much more money would show up? 10,070,000. 10,070,000. So let's ask you a quick question, and this is breakout room number 1. Joel, Dunstead, Max, Michaela, and Priyanshi. Forgive me for killing your names, all of you. All right? If you were a producer and the director comes storming into your office screaming, I need another $10 million. I need another $10 million for this movie, otherwise it won't be made the way I want it made. You as the producer need to say either yes or no. And you are just a cold-blooded business person. All you care about is the return. What should you say to this person? They ask for $10 million, how much more money you're going to get? Anybody from breakout room 1?
So it's 170, right?
So if you spend 10 million more as a producer, you're going to get 10 times 1.07, which is 10,070,000. That sounds like you're going to make an extra 70,000, right? Yes? No?
Sorry, isn't it 700,000?
700,000. You're correct. Thank you. You're going to make an extra 700,000. I stand corrected before you. So as a producer, bring up room 1. You think yes, you do it, or no, you don't do it?
Yes.
Thank you very much. Whoever said that. I would say, I don't think I would do it. Why? Because I like the idea of $700,000. $700,000 sounds like a lot of money to me as a college professor. Maybe not to you, okay, but to me, $700,000 is a big chunk of change. But what are we missing? What we're missing is this upper and lower idea here. And the upper and lower idea, I'm going to make it in yellow. It could be as low as spend 10 million, get 10 million. Or it could be spend 10 million and get an extra 140,000. Sorry, extra 1.4 million. I'm off by a decimal place. There is a chance that we're not going to get any extra payback. Does that make sense? Because the 95% range means, while 1.07 is our best guess, there's uncertainty associated with that 1.07. It could be much bigger.
Shouldn't you still invest the money though? Because like on the lower 95%, you're still getting that 1 million back or 10 million back.
Honestly, and so this is off topic for 30 seconds. I would say absolutely positively no. Why? Because lifetime gross is the amount of money sold in the movie theaters, and the movie theaters take like a 40% cut, and they only give the producers back 60%. It depends on exactly what kind of movie and the agreement, but basically they take a 40% haircut to show the movie, clean the movie theater, do the popcorn, all the distribution. So if I'm a producer and I kick in $10 more million to that director, I'm going to get back $6 million if I only make $10 more million in sales. That's sort of real life. So that producer has to say, that director has to say, yeah, you give me 10 million, you're gonna make 20 million or 30 million dollars more in ticket sales. And then I say, okay, sure, no problem. Does that make sense? Let me say, learn from anywhere. It's a very unique way of teaching. You get questions, but it's like, did anyone hear the answer? Rithvik, did anyone hear the answer?
I heard it.
Okay, great. Somebody heard the answer. Did it make sense?
Yeah.
All right, but that's because I pay you. So I'm expecting that. All right, next question. The movie 50 First Dates had a budget of $75 million and made a lifetime gross of $120 million. What is the error residual for this observation? The model underpredict, oh, sorry, we missed one. Predict the lifetime gross of a movie with a budget of, well, it says 20 million, let's do 75 million. Predict the lifetime gross of a movie with a $75 million budget. Okay? Predict lifetime gross. Go ahead, Max.
Be like 80 million if you spend 70 million.
With a 75 million budget. And how do we do that? Go ahead, somebody else. Looks like Rashawn. How do we actually do this calculation?
Oh yeah, I did, Professor. It's 75 times 1.07.
Okay, so it's equal to 75 times B18, because that's where the coefficient is, plus, go ahead, keep going,
Plus B17.
plus B17 plus the intercept. So it's 75 times B18. B18 is the coefficient on budget, plus the intercept. And we're getting a prediction of basically $96 million. So our prediction is we're going to sell $96 million of lifetime growth. Does that make sense on how to come up with number 3, predict the lifetime growth of a movie? Go ahead.
Just to clarify, if we did check the box, the intercept there would say 0, correct?
It should.
Okay.
The line shouldn't even come up. All right. And then you shouldn't even add the intercept. All right. The next question. The movie 50 First Dates. I've never heard of this movie. Has anyone heard of this movie? Raise your blue hand. Five people. Okay, I don't feel bad. The movie 50 First Dates had a budget of $75 million and made a lifetime gross of $120. What is the residual, or the error from this observation? How do you calculate the error residual? It's the difference between what actually happened versus what you predict to happen. The error residual is the difference between what actually happened versus what you predict. Okay, so what's the formula for the residual? The residual slash error difference between actual and prediction. So what's our residual?
I got 24.
All right, and how do we do that?
I did 120 million.
So 120 million minus minus 822. So we get a residual of 24 million. Did the model underpredict or overpredict lifetime gross? The model came up with 96. True was 120. Was 120? Is this an underprediction by the model or an overprediction?
Underpredict.
Underpredict. Exactly right. Please pat yourself on the shoulder. So that would be an underprediction by a fair amount of money, $30 million. 25 million. All right. Number 5, create an indicator variable for a movie released in the summer. What do we think is summer? Forgive my Boston accent with a master. Summer.
June to August.
Okay, June, August. Does everyone agree that June, August is a good for summer? All right. In Hollywood, it's actually includes May. Memorial Day weekend in North America is the beginning of the summer season, and they oftentimes release the blockbuster in May, but we'll just use June to August to keep things nice and simple. So we'd like to go to the data sheet, and I'm going to be quiet for a minute. Your job is to create a new column of data. In column P, we'll call it summer. And this is a Boolean, an indicator, a true, false. All those words mean the exact same thing. 0, not summer. 1, it is summer. And where do we find the month? We find the month in column H. So you need to create an if statement for summer. I'll be quiet for a minute or two. God bless you. Some of you are very fast in Excel. If you're very fast in Excel, can you come up with 2 different if statements that do the exact same thing? 2 different if statements. So we'll call summer in column P summer or. And we'll call summer in column Q summer and. And you'll see why I'm calling them or and in a second. Let's create an if statement using the or function. And the or function, there's an Excel video that talks about the logical functions. I believe it's advanced number 2 video on the all sections website. So we can say equal if, and then we can say or. So what's summer? It's either 6 or 7 or 8. It's either June or July or August. So the or function will be equal H2, which is where the month is equal to 6, comma, H2 equals 7, comma, H2 equals 8. Close parenthesis. By saying equal, left parenthesis, OR, left parenthesis, H2, I'm saying if it's 6 or 7 or 8, any of those 3 months, we're in summer. Comma, put out a 1, comma, otherwise put out a 0. The first movie came out in December, so we should get a 0. The second movie came out in December, we should get a 0. Third movie came out in July, we should get a 1, May 0, and then another 1. Let's copy this whole thing down. Move our cursor, which is a white open plus sign, to the bottom right corner until it becomes a thin black plus sign, and double click when it turns thin and black. And we get a whole series. Looking at them pretty quickly, looks like we did a pretty good job. Let's try a different if function. Let's try an and function. Equal if, and, left parenthesis. What do we want to say here? Anybody have any ideas how I do it with an and? We can flip the logic. If H2 is less than 5, oh. All right, and's not going to work. That's an idiot. Sorry. Not the and function. I am. We can do a different one. The one I was thinking of was if H2 is less than 6 or H2 is greater than 8, put out nope, 0, otherwise put out a 1. That was the one that popped into my head. Copy this down. And we get the same series of data. The whole idea of this is that we can do lots of different logical tests and come up with the same kinds of data. There's not just one way to do these logical tests. So what I'd like you to do is run a regression where column P, the summer dummy variable, is the X, and lifetime gross is the Y. And if you're really fast at it, can you come up with simple explanations before I send you off into breakout rooms to discuss the explanations of the coefficients? Okay? So let me do it. We'll take data, data analysis, regression. The Y range is okay. We have to just change the X range. And the X range is column P, P1 down to P 1560. I click OK, and I get an intercept of 60.7 and a coefficient on summer of 21.2. So I'm going to set up breakout rooms, and the breakout rooms are designed to answer 3 questions. 1, simple explanation for the intercept. 2, simple explanation for the summer coefficient. And number 3, the question on the handout is, if you are a director, would you recommend releasing a movie in the summer? Why or why not? Should you recommend releasing a movie in the summer? Why or why not? Let me open up the same rooms, and I'll see you in about 3 minutes or 2 minutes. So the rooms will close in about 45 seconds. We only have about 3 minutes left in today's lecture, which makes me sad. I'll miss you. But don't worry, I'll see you on Friday. Okay, so the breakout rooms are still going, but room 5, since you're all back, Ali, Kevin, Raphael, sorry, Ritvik is part of room 5, but we won't include him. He's the TA, he already knows the answers. So room 5, what does the intercept tell us? In a second, room 6, Ayush, Anika, Brendan, what does the coefficient tell us? And room 4, Stephen, Goodshot, Alana, and Jacob, should you open up movies in the summer? Yes, no, and why? Does that make sense? So 5 does intercept, 6 does the summer coefficient, and 4 does the big question. As a producer, do you move your movie to the summer or not? All right, everyone's back. Sorry, I hit the wrong thing. Don't join the breakout rooms. Go ahead, room 5, intercept.
We said that based on the intercept, it just means that if it's not a summer movie, it's projected to make 60.7 million.
Excellent, excellent. Non-summer movies on average make about $61 million. All right, breakout room 6, the summer coefficient.
For summer, we kind of came that if it is in the summer, you're going to add on average $21 million.
21 million on top of the 60, so summer movies on average earn about 81 million. And last but not least, the last group, should we release movies in the summer, yes or no?
I think we should release movies in the summer, looking at the 21 million plus the lower and upper 95%. It ranges from 12 million to 29 million.
Yeah, all right, so it's pretty, we definitely earn more money in the summer. And why do you think we earn more money in the summer? I know I didn't ask this question ahead of time, but why do you think? What would be the reason, the business reason? Anybody? Feel free to unmute yourself.
Well, I don't know if this is what you're asking, but if you look at the T statistic, it's more than 2, so you're pretty positive by a good margin that you're gonna earn more money.
I was just asking kind of a simple business question. Why do people see movies?
Oh, never mind.
Well, I guess going back to your earlier statement, why Blockbuster releases things like college ends. So like
College ends, high school ends. People have free time. Woo! And guess what you have since it's 11 o'clock? Free time. So thank you very much for watching. I look forward to seeing all of you on Friday, and have a very safe 2 days. And I'll stay online for those of you who have more questions. Thank you very much, Raphael. Great answer for the T statistic, for noticing that. Impressive.
Thank you.
Thank you.
Thank you.
Thank you.